Let's begin with the concept of a virtual private network, as well as the various types of VPNs, virtual private networks that can exist, and also why they're needed. So one of those options is called a site-to-site VPN. And as the name implies, it's between two sites. So for example, let's say we have over here, this all represents our headquarter location, and over here, this represents branch 1. They're both connected to the internet, and we want to have connectivity between the two sites. So what we could do is we could build a VPN tunnel, for example, from edge 1 over here to branch 1, then traffic that needs to be routed from this part of our network at headquarters site over to the branch office, or vice versa for access that the branch might need over here to resources in the corporate location. They could build a site-to-site VPN tunnel, and that way the traffic as it goes back and forth, the traffic would be encrypted here by this edge device, shipped over the internet, and because it's encrypted, anybody stealing that data can't make sense of it because it's encrypted, the branch office would decrypt that information and then forward it on to its destination. Another option for VPNs is called hub and spoke. And here's what that could look like. We could have our edge 1 or possibly edge 1 and edge 2 acting as hub devices. And let's say we had 40 or 50 remote locations. We could then have a IPsec tunnel from our edges out to those remote locations. For example, branch 1, branch 2, branch 3, branch 4, etc. And that's an example of hub and spoke. And then with an additional hub here, we have some fault tolerance in case we lose a single device. So in that case, we'd have edge 2 also with tunnels out to each of our remote sites, again for some fault tolerance. So if we were to draw that out, the site-to-site would be like this, and the hub and spoke would be like this. Another option for VPN tunnels is known as a remote access VPN. And the biggest difference here with a remote access VPN is that we're usually dealing with just a single device. For example, let's say we have this user right here who's normally at PC 110. They go home, so I'm going to draw their little house here. There's our user, maybe that's their laptop. And if they want to connect to corporate headquarters here, they could launch some software and build a VPN from their device all the way to our VPN edge here to get access to the corporate network. And that's an example of a remote access VPN, normally done with some software here at the client computer, and then some device at the headquarter location like a firewall or some other device terminating the other end of that VPN tunnel. So let me clean some of that up a little bit, and let's chat about protocols used as part of VPNs. Now, a very popular protocol that's been out there for a long time is called IPsec for IP security. Think of like every packet, IP packet that's being sent. Before it's being sent, it's encrypted and protected and shipped over the network until the receiving side receives it and decrypts it. Now, the reason that IPsec has been around for decades is because it is not just one thing. It's evolving over time. So IPsec is a framework or umbrella of protocols that can work together, including protocols and algorithms for authentication to prove who devices are, as well as algorithms to encrypt the traffic and also algorithms to help verify that the data hasn't been changed as it's being sent over the network. And so when we're doing site-to-site VPNs, that is going to be IPsec-based. And if we're doing hub and spoke, that's also going to be IPsec-based with that suite of protocols. However, if we're doing remote access VPNs, that could be IPsec-based, or it could be using TLS, Transport Layer Security Technology. So either IPsec here or TLS. So for our discussion in this set of videos, we're going to be focusing on site-to-site IPsec VPN tunnels. So with IPsec, at the end of the day, the goal is protected communications, for example, from here to here, so that we're encrypting everything going over, for example, the public internet. However, what's not super clear most of the time when I talk to people about IPsec and VPNs is that there's actually two tunnels that are being built with IPsec. And so with IPsec, the names of these tunnels are slightly different depending on which version of IKE that we're using. Now, IKE is an acronym for Internet Key Exchange, and with IPsec, we can be using IKE version 1, or we can be using IKE version 2. And in either case, they still have the two tunnels in place. Let me explain what those tunnels do. The first tunnel, I'll go ahead and label this as 1 here. The first tunnel is used between the two devices that are building the IPsec tunnel for negotiation and setting up so they can communicate securely back and forth. And I like to think of that like a private party line between the two devices, in this case, edge 1 and branch 1. And then once they set up that private party line, and they can communicate back and forth and negotiate, they're then going to negotiate that second tunnel, and the second tunnel is actually what's used to carry the user traffic. So that's going to be tunnel number 2. And I'm going to refer to that as data plane traffic. Think of data plane like the actual user traffic. So if this user right here is communicating out here with this device out here, that traffic would be routed through the internal network here. At the edge, it would be encrypted, shipped over the second tunnel here. The branch would receive it, decrypt it, then forward it to the final destination. And so that logic is the same with IKE version 1 and also IKE version 2. So we have our first tunnel, that's the private party line, and the second tunnel is the data plane. Again, data plane referring to user traffic being encrypted and sent over the IPsec tunnel. So we color code those as well. This is our first tunnel right there, and our first tunnel, and our first tunnel here. And I'll put the second tunnel in the pink color. So IKE version 1 and IKE version 2 handle things slightly differently, but the logic is pretty much the same, and that is a control channel here between the two endpoints, in this case edge 1 and branch 1, and then a second tunnel, the actual IPsec tunnel itself, to carry the data plane traffic, the user traffic going back and forth. Now in IKE version 1, they call these two tunnels phase 1 and phase 2. And specifically, they're called IKE, as in Internet Key Exchange, phase 1 and phase 2 tunnels. And oftentimes, this phase 2 tunnel is also called the actual IPsec tunnel. So if somebody says we're using IPsec VPNs and IPsec tunnels, the actual IPsec part of it for encrypting the user traffic going through is the phase 2 tunnel, also sometimes called the IPsec tunnel. Also, there's a common term called SA, which stands for Security Association. So if you see an IPsec SA or a phase 1 SA or an IKE SA, think of it just like the agreement between the two devices. So then for IKE version 2, instead of calling it phase 1 and phase 2, the initial tunnel is called the IKE SA for Security Association, and then the second tunnel is referred to as the child SA. But once again, that child SA really is the actual IPsec tunnel that's being used to carry data plane traffic. And the reason I point this out is because in the interface, when we're working with FortiManager or the FortiGates directly themselves, sometimes they'll use the terms phase 1, phase 2, even if we're using IKE version 2. So at the end of the day, just think of two tunnels that are being created. The first one as a control tunnel between the two devices, they can talk securely, and the second one is the actual IPsec tunnel that end user traffic goes through. So for the balance of our discussion here, I'm just going to call these phase 1 and phase 2, or tunnel 1 and tunnel 2, regardless of the version of IKE that we're using, because that'll be consistent, and also it'll agree better with the interface once we get into that. So to set up and negotiate these tunnels, let's go ahead and put them both back here. So I'll put the first tunnel here, and the second tunnel I'll put right here. And let's talk about, in the first tunnel, let's talk about some of the things they're going to have to agree to negotiate to set up that initial tunnel. And the way I like to remember this is the word haggle, H-A-G-L-E. So they're going to haggle back and forth to negotiate and set up that initial tunnel. So this is the first tunnel. So here are the basic 5 things they need to have agreed upon to go ahead and set up that initial tunnel. They have to agree on the encryption that they're going to use, meaning the encryption algorithm. Most of the time we're going to be using some flavor of AES. Now, the actual encryption algorithm itself isn't the secret sauce. The secret sauce is the actual keying material that we throw in along with that encryption algorithm that allows no one to determine what that data really is unless they have that same keying material. And as far as getting the keys, that's where the G comes in. That's for group. And specifically, that's for the Diffie-Hellman group. And the Diffie-Hellman is an algorithm that's run between these two devices that allows them to generate shared secret keying material that they can then use with their agreed upon encryption algorithm. Also, to verify data integrity, we're going to use some hashing. So the hashing technology or hashing protocol needs to be agreed to by the two devices for the first tunnel. The A is for authentication, how these devices are going to authenticate to each other. They can use a pre-shared key configured on both of them, or they could use digital certificates for the authentication, depending on what we have set up. So the L represents lifetime. So that's all the things that these two sides need to negotiate to build up and bring up that first tunnel. Now, once that's successful and they have that initial tunnel up, they'll then start negotiating the second tunnel. And I'll put that in this pink color. So for the second tunnel, the actual IPsec tunnel to carry the data plane traffic, there's the option to set up what's called PFS, Perfect Forward Secrecy, which allows the two devices to go ahead and run Diffie-Hellman again to generate another different set of keying material for the benefit of encrypting data on that IPsec tunnel. So with PFS, if we elect that, then we'll specify which Diffie-Hellman group to use again with that. As far as the encryption algorithm, that's another element they'll need to agree on. There's also lifetime for that second tunnel. And the benefit of having a lifetime that's not forever, for example, is that if we have this tunnel that's up for an hour and it's being used all the time, right before this tunnel is expiring, the firewalls will use the IKE phase 1 tunnel, and they'll go ahead and initialize and set up a brand new second IPsec tunnel and have it active before the old tunnel times out. And that way, customers can have no interruption service. And also, we're not going to be using the same keying material if we're using PFS for every tunnel. So the more oftentimes we change it, for example, if the lifetime is an hour, it makes it less likely for somebody to reverse engineer or possibly discover what that key is, because it's changing periodically. We're also going to need to agree on hashing for that second tunnel, and oftentimes we use a thing called an HMAC, Hashed Message Authentication Code. However, that sounds pretty hard to say, so hashing is just a way of verifying data integrity for each of the packets that are being sent. Now, as far as some other options that exist, when we set up IPsec tunnels, we can have it tunnel-based, And that's often called policy-based. And with tunnel-based, effectively, we just train these firewalls that, hey, if you get this traffic going for a certain destination, go ahead and encrypt that data, ship it over to your buddy, who will then decrypt it. So these two firewalls could be anywhere reachable on the internet, and the two firewalls, as they send data back and forth, would encrypt the data, ship it over to their peer, and then the receiving side would decrypt it. There's also an option called interface-based. And the biggest difference there is with interface-based, we're going to actually have an IP address associated with the tunnel. And that way, if we have an IP address associated with this logical link between edge 1 and branch 1, we could then do things like dynamic routing protocols and other routing techniques because we actually have an IP address associated with that network between the two peers. Also, a common term when working with VPNs is the transport network and then the overlay network. So the transport network would be the actual routers and switches and forwarding of the actual data, and then the overlay is the logical overlaying on that transport network of our IPsec tunnel, where if we're using an IP address associated with it, it just appears like one logical network between these two devices. Now, one of the challenges also with having something called tunnel-based and interface-based is that a lot of the syntax we're going to see in the interfaces is going to say tunnel even if we're using interfaces. Or if we're talking about IPsec tunnels in general and we're using interface-based, sometimes that can get confusing because it's the same word being used in a different context. And then one other thing I'd like to share with you regarding implementing our IPsec tunnels in a site-to-site fashion is that there is more than one way of doing it. So let's talk about some of those options regarding how we could implement the IPsec site-to-site VPN. Number one, we could just go directly to the actual interfaces for the, in this case, the VDOMs or the firewalls, and configure it there. Configure it on the edge, configure it on the branch, and be done. So I'll call that one direct GUI at FortiGate. Now, if we happen to be using FortiManager, we have even more options. One option with FortiManager is we could create CLI scripts and push out the commands for the IPsec tunnels via CLI. Or we could also use a provisioning template, and there's a specific one just for IPsec. So we could use a provisioning template, put in the details, and then push it out that way. Another option is we have the VPN manager as part of FortiManager. And the VPN manager can help us in putting all the pieces together for our tunnel. And there's actually one other option, and that is in Device Manager. We could actually do it right there in the VPN section in Device Manager. And let me also share with you what I feel is the toughest part of setting up IPsec tunnels, and that is this. When you're setting up site-to-site tunnels, there are several components that could go wrong. For example, if we don't agree on all the parts for the initial tunnel here, the initial tunnel is not going to be built, and the second tunnel is never going to work. Or we could have problems with the negotiation or agreement on the second tunnel, the actual IPsec tunnel, or we may have filtering in place that's not allowing all the protocols to go back and forth that we need to between the two ends of our tunnel. And I've mentioned this before in many other courses, including this one, and that is the technique of wrap has never been more important than it is when working with IPsec. And this is what we should look at when we're troubleshooting. And the R is for routing. If we want to encrypt the traffic from these three networks going to, for example, this network over here, we need to make sure that the routing is in place to forward the traffic through the correct firewall to make sure that that firewall can do the encryption. And the same thing here, if we want this client going through branch 1 to be able to reach these subnets, we need to make sure branch 1 has a belief, routing-wise, that it can reach those by leveraging the tunnel. So we need to make sure routing is in place. A for address translation, because we don't have to do NAT between the branch office over here and our corporate office. We don't really need to worry about address translation, that's the A, but we do need to worry about permissions. And here's why. Just because we set up an IPsec tunnel doesn't mean that our firewalls are like, hey, let that traffic in. We still have to have rules, policy rules, on our firewalls to permit initial flows of traffic. If we want like PC12 to be able to reach PC110 here, we need to make sure that traffic is allowed this direction through firewall 3 and this direction through firewall 2. And then when it gets to the edge, that the edge recognizes that it needs to be encrypted, ship it over to branch 1, who will decrypt it. However, as that traffic comes into the branch firewall, we need to have permission saying, please allow traffic that's coming in on our tunnel interface. If it's going to our inside zone here, please allow that to go through. So in setting up IPsec, a huge part of it is the planning and the details as far as what we want to have happen. And then there's always going to be a little bit of troubleshooting as we make sure the routing is right and everything else to make those VPN tunnels actually work. So here's what I propose we do. In the next video, let's put a game plan together regarding what we want to accomplish with our IPsec site-to-site VPN tunnels, including the first tunnel and the second tunnel. And then with that game plan in place, I'll walk you through step by step the implementation and verification of that IPsec site-to-site tunnel. So I'll see you in the next video in just a moment. Hey, thanks for watching, and subscribe right here to get the latest information from CBT Nuggets. And if you're new to or considering a career in the world of IT, head on over to CBT Nuggets and sign up for a free trial.